Welcome to my channel, Waiting on Parts. In this episode, I stuff a Princton 5F2A guitar amp into a 1952 Silvertone radio. The 5F2A is identical to the Fender Champ, however this schematic has a tone knob and an extra capacitor, which allows you to utilize all the controls on the front of the original Silvertone radio.
Yeah, it sounds good, Aldo.
Very just boom.
This is a 1952 Silvertone AM radio. It was once sold at Sears Roebuck, but today could be had on eBay for around 50 bucks. There's not a whole lot of demand for 1950s AM radios. This little radio is known as an AA6, which stood for All American 6.2 Radio. They were cheaply built without power transformers and sold to the American public. The reason why Europe banned these radios was if you were to put the non-polarized plug in the wall incorrectly, the radio's chassis would become hot or electrified, which is not safe. This radio arrived from transit in several pieces. I was refunded my money, but it was obviously going to require some work to make it look good. I also put in new capacitors in the power supply because my intentions were to use the amplifier from the original radio. However, after hearing how bad it sounded and how potentially hazardous a hot chassis would be, also having 120 volts on your guitar strings is not ideal. I stripped the radio of its components and saved the tuning capacitor and the original steel chassis. The original bakelite shell had a volume knob and a tone knob and a tuning knob. Since I only had two holes available for potentiometers, I decided on using a Fender 5F2A Princton circuit. This amp was used a lot in recording studios at the time because of its clean low wattage, single-ended triode circuit. This amp breaks up predictably, making it sought after by blues players such as Booker T and the MGs. Once I had a good idea of where the tubes and the transformers are going to be placed, I bent the chassis and tried to determine how many and where to place the terminal tag strips. This was my first attempt at making a custom chassis. A couple things to be aware of. If you're using a cheap bender like I did, don't go over 1mm thick aluminum and use a lot of clamping force or the aluminum plate will slip on the bender. The chassis is visible through the tuning window and the original radio chassis is full of holes and unsightly, so I bent a cover to go over the old chassis and cover up its holes. My cover is also 1.5 inches longer than the original radio chassis, which allows me to put the power transformer as far away from the sensitive input circuit. I covered the aluminum plate with blue tape to keep the bender from scratching it all up. I then cut holes for the potentiometers and the tuning shaft and ensured that it fit in the chassis properly. This 5F2A amplifier is super simple, however it's susceptible to ground noises. If you have bad grounds, you will get weird oscillations, pops, screeching. That is why I used star washers to bind the two chassis together to ensure a perfect ground. I took the power transformer apart so I could polish the iron core to a mirror finish. Both the transformers are visible from the back of the radio, so I had to make them pretty. I use an automotive grade 2-part clear coat for a super durable and glossy shine. Applying this clear coat, I get the best results by spraying only the horizontal surfaces. I use a tack cloth to clean off the part before I spray it. polished the iron core of the transformer by starting with 220 grit sandpaper and moving on to 400, moved on to 600, 800, then 1000, 1500, 2000, 2500, and then finally ended on 3000 grit sandpaper. If you polish your transformers after you sand them, you're going to need to make sure they're free of any wax or polish to ensure the coating sticks to the surface. I taped off the transformer openings and the tube holes to avoid getting spray on the underside of the chassis because we want perfect grounds. I like how the old chassis divides the primary input from the output. That might actually help with some noise reduction. I had to buy 2 new long shaft 1 meg pots with a power switch. I didn't have a lot of room for knobs or switches on the front, so I put a switch on the tone knob for extra bass or extra treble. I added these terminal strips to the metal chassis when it was outside of the aluminum chassis to avoid heating up the newly applied coating on the aluminum. Remember how I said this circuit was susceptible to ground noises? I used tools to tighten all my accessories. I'm wiring up the 5-volt heater filaments. Twisting the heater wires helps reduce AC interference. The red wires are high voltage AC going to your rectifier. Green is your 6-volt AC filaments for the 6V6 and 12AX7. I steered the heater wires going to the 12AX7 away from the potentiometers. They are susceptible to AC hum. I didn't have a 2-post terminal strip, so I put the center tap on the 6V6, which was not a good idea. The resistors arced out on the 6V6 socket and turned the resistor all black. The amp sounded great at low volts on the Variac. However, once I put it on the outlet, it started oscillating and screeching. I did some research and found out that it was probably the primaries on the output transformer, and I would have to reverse them. So this is my first attempt at a true point-to-point wiring. I did not use the turret board because this chassis is only 11 by 4 inches. There simply wasn't enough room for a turret board. And quite frankly, after building about 4 amps, I actually like doing it point-to-point like this. It was easier. So when wiring up the caps, you gotta observe the polarity. I test every component before putting them into my project. In the original schematic, you would wire a component to a terminal on the turret board, which contains your resistors and capacitors. But with point-to-point, you essentially use the resistor or the capacitor itself, no wire or turret board, to bridge the component directly to the destination like the tube or transformer. Here I use an oscilloscope to find the outer foil end of the capacitor. This reduces noise if you put the foil end towards the ground of the circuit. I got lucky on this amp. As soon as I turned it on, it started working from the get-go. I didn't have to do any troubleshooting or anything. It did go into oscillations. I had to switch the primaries, but other than that, it played instantly. But if you run into issues, you can email Silvertone and they usually get back to you within a day. The Silvertone 5F2A kit is normally $530, but I got just the small parts kit and the transformer for $300. I then bought a Jensen mod speaker for about $45. I didn't need the reproduction Fender chassis because I was going to reuse the Silvertone radio chassis. Here I'm putting in the tone stack and wiring the volume pot. I'm bringing the amp up on a variac.
80 volts. We got filament.
Watch how I brush the chassis with my finger. This is how I test to see if it's electrified. I was in shock because I've never had an amp fire up without any troubleshooting. Once I took the amp off the variac and plugged it into the wall, it started arcing and oscillating and screaming. Watch for the arcing on the 6v6. Once I switched the wires on the output transformer, the amp was up and running and sounded fantastic. I kept the original radio's dial indicator and tuning capacitor. I replaced the original indicator with a LED hard ceramic one. However, they are super fragile and it ended up breaking 2 red ones trying to install it in the chassis. I made a short video of how the original tuning capacitor came apart. This way I could reassemble it if I needed to modify it. I ended up cutting the tuning capacitor down to 1/3 of its original size. I wasn't going to actually use the radio feature. I'm going to use it purely as an amplifier. I wanted to retain the dial indicator feature because it's going to look cool lit up. Here I'm experimenting with getting DC 3 volts for the LEDs from the rectifier's 5-volt AC heater supply, which is not originally in the schematic. It's normally off the 6v6, but had more room on this side of the chassis. I ended up using a diode and a 330 ohm resistor to rectify the 3 volts from DC. Thanks for watching. Please like and subscribe.